Algebra 2, Chapter 6.1, Exercises 1 through 13. This section covers graphing cubic functions, and I'm going to go over these odd number problems in the set. Problem 1, graph the parent cubic function fx equals x cubed and use the graph to answer each question. The first thing I want to do is sketch a graph using the coordinate grid provided. And to do that, I'm going to construct a table. Now, if you watched my most recently recorded video that I did yesterday, you can see a lot of this worked out. So if you have an input of x and then output of f of x for the function f of x equals x cubed, we're going to use the input points -2, -1, 0, 1, and 2. Okay, if we input -2, well, we're going to have -2 cubed, which is -2 times -2 times -2, which is -8. Next, for input of -1, we have -1 cubed, which is going to be equal to -1. If you take for input of 0, 0 cubed, well, that's going to be obvious. We have 0 cubed is 0. 1 cubed is 1. And lastly, 2 cubed is equal to 8. Go ahead and write that, 2 cubed. And then we can use our coordinate grid to mark. We have -2, -8, our first point. -2, -1, -1, there we go. 0, 0. We have 1, 1. And the last one we have is 2, 8. And then sketching this graph, I'm going to try to do this freehand. So we come like this. It's coming up pretty steep, and then here, as we go to the origin, it kind of takes a little sideways jog. And I could do this a little better, and I didn't get what I wanted here to rotate. But you can see that that's basically what it looks like. And in fact, I'm going to go ahead and redo this one because there we go. Let's redo it. I want to get it in one continuous. That's a little better. There we go. Okay. Let's take the function's domain and range. Our domain is going to be all real numbers, which I like to write in interval notation, greater than infinity, less than infinity. And for this function, our range is going to be the same, greater than infinity, comma, infinity. All real numbers, each. Identify the functions and behavior. Well, as x approaches infinity, comma, f of x approaches infinity. And then as x approaches -infinity, f of x approaches -infinity. Identify the graph's x and y intercepts. Well, we have the origin 0, 0. So x-intercept is, we could say, is equal to 0. So well, let's just say it's going to be 0, comma 0 as a coordinate pair notation, and y-intercept is going to be the same. Coordinate pair 0, comma 0. Identify the intervals where the function has positive values and where it has negative values. Well, as we go to the point of change, it's going to be here at x equals 0. So we will say positive, we will say f of x is greater than 0 on the interval of 0, greater than 0, less than infinity. And f of x is negative or less than 0 on the interval from negative infinity, greater than negative infinity, less than 0. And we can see that with the graph quite well. Identify the intervals where the function is increasing and where it is decreasing. So we can see that the function is increasing everywhere. So we will say f of x is increasing on all real numbers. You could write it out verbally, but I'm just going to put this in interval notation on greater than negative infinity to less than infinity, increasing everywhere. And where is the function decreasing? The function, or instead of the function, I'll just say f of x. F of x is never decreasing, or never decreases. Okay. Tell whether the function is even, odd, or neither. Explain. Well, there are a lot of indications the function is odd. And there's a formal way of articulating that the book gives and other books give. I'm not particularly enamored by it, but the way this works out is f of negative x equals negative f of x. I don't particularly like this. I like really explaining the odd symmetry. And we have, for g, we have f of x. They say symmetry about the origin, but I would rather put it this way: has 180-degree rotational symmetry about the origin. Rotational Okay, so that's how you explain the rotation. So another indicator of odd is when you have polynomial function, if you have the power, in this case x cubed, so we have f of x equals x cubed. This value 3 here, this exponent, is an odd number. So when you have a power function, that the power, or the exponent of the base x, or the base of the independent variable, is determines whether that is an odd or even function. Even number, if that exponent is an even number, that's an even function. If that exponent is an odd number, that's an odd function. Works every time, as far as I can see. Next, describe how the graph of g of x related to the graph of f of x equals x cubed. And so I'm going to just go over the odd ones in this and leave the viewer to do the even number problems. 3. G of x equals negative 5x cubed. So this value, and I'm going to put like the kind of a general form here. I'd say vertex form. It's not exactly vertex form. So I'll say f of x is equal to a times quantity 1 over b. And we have x minus h cubed plus k. And this a is what vertically stretches or compresses. So this will widen or narrow the cubic function. Widens or narrows. So anyway, what we have is this 5. That's going to be a vertical stretch. So I would summarize this. F of x is vertically stretched by a factor of 5. And we also have the negative sign. Negative sign will reflect about the x-axis. So f of x is also reflected about the x-axis. Okay. Let's go on to problem 5. What we have is g of x equals 23x cubed. And what this does is this takes the, I'm going to write that form again, f of x equals a times quantity 1 over b times x minus h cubed plus k. Okay, what I don't like to deal with this b inside, because what you're doing here with the b, you're going to be horizontally stretching or compressing. I like to go ahead and work it out so we figure out what a is. And doing that in this case, we're going to take this 3 and cube it, so we get 27x cubed. So we've changed this to an a essentially by undoing the parentheses and putting the a outside. So we will say f of x is vertically stretched by a factor of 27. Now what you're going to have is, if you work this out and just change this, it's going to end up, I think, being horizontally compressed by a factor of 1/3. I think that's how that works out. I don't like to do it that way. I like to convert it all to a vertical stretch or compression. The next problem we're going to look at here in this video lesson is number 7. So what we have is 1/4 is out here in front. We have g of x equals 1/4 x cubed. So in this case, a is equal to the fraction 1/4. And if a is less than 1, then we have a vertical compression. So f of x is vertically compressed by a factor of 1/4. Okay, that's that one for number 7. I think 6 translates left to right. Anyway, okay, here we have 9. G of x equals quantity negative 2/3 x cubed. What I'm going to do is, again, as I did in problem 3, I'm going to take this negative 2/3 outside and cube it, and then leave this x cubed here. And we cube this negative 2/3 cubed, we have negative 8 over 27 x cubed. So what I'll say is g of x, or f of x, we describe what happens to f of x, right? F of x is compressed by a factor of 8/27, and the negative sign does what? And reflected about the x-axis. Okay. Here we have a different set here. Identify the transformation of the graph of f(x) equals x cubed that produce the graph of the given function g of x. Then graph g of x on the same coordinate plane as the graph of f of x by applying the transformations to the reference points -1, -1, 0, 0, and 1, 1. And so we have our a value is 1/3. So if we had our, one way to look at it is this. You remember we had at the beginning of this worksheet, we had x, and I'll put g of x here. Well, if we have x is -2, we have g of x is going to be 1/3 of -2 cubed, which is going to be -8/3. For -1, we have 1/3 of -1 cubed, which is going to be -1/3. So basically, we're taking every input value, we have 0, 0, and we're multiplying that by 1/3. So we have 1/3 times 1 cubed here, which equals 1/3. And then if we have an input of 2, we have 1/3 of 2 cubed, which is equal to 8/3. So we have some points to work with. So for negative 2, we have negative 8/3. Negative 8/3 is a little bit greater than 3/3, so it's going to be like this. For negative 1, we have negative 1/3. So it'll go like this. We have 0, 0. We have 1 comma 1/3, and we have 2 comma 8/3. So that's going to look like this. We graph like this. It'll look something like that. All right, that's pretty good. And let's see, identify the transformations. Well, we will say, what are the transformations? We'll say vertical compression by a factor of 1/3. And the reference points that we're going to change, well, negative 1 comma negative 1. So I'll say reference points are, and so remember we took the negative 1, negative 1, well that would be this one right here. So we would have negative 1 comma negative 1/3. Our origin stays the same, so we have 0 comma 0. And our last reference point is 1 comma 1/3. Okay, so these would be our answers for problem 11. Next, problem 13. There we go, problem 13. We have g of x equals 20x plus 1 cubed plus 2. And for this, in this, I'm going to write over to the left here, for kind of our general form here, we'll have a times 20x minus h cubed plus k. So we have x plus. So what we are doing is we are shifting to the left. X plus moves to the left, x minus to the right. So translates, we'll say translates one unit to the left. And this 2 will translate 2 units up. So we can go take this and take each reference point. That's what I'm going to do in this one. I'm going to go 1 to the left and 2 up. This origin, I'm going to go 1 to the left and 2 up. This 1 comma 1, I'm going to go 1 to the left and 2 up. It doesn't look right. 1 to the left, 2 up, 1 left, 2 up, 1 to the left, 2 up. Yeah, I guess that is right. And I'm going to go ahead and what are the reference points? Well, I'm going to go ahead, before I do that, I'm going to sketch. I'm going to be clever with my notebook software here. Okay, so I'm tracing over, right? Now watch this. What I'm going to do is I'm going to take this line that I traced over and just move it. I'll move the inflection point up here. Look at that. There. All right. And what else? The reference points. What are the reference points? Well, what we did is we'll take negative 2, comma 1. The origin becomes negative 1, comma 2. And the last one's going to be zero, comma 3. So really that's it. So I hope this can help. Good luck on your other exercises. And thanks for viewing.